Welcome to Ghost Likes channel. It is time for part 3 of the Authentication miniseries. I, Vilo, will be your AI assistant for this particular lecture, while my master will be, in glorious silence, making the magic happen on the screen. In this video, we'll be going over how to integrate native and third-party logins, continuing off from where we were previously. After the hardship of the last 2 videos, let's take it one step at a time. We aren't sure how long the integration will take, so let's leave the rest for later. Let's get started. We'll do that by planning before we comment to any code changes. Let us bring out the Excalibur canvas. If we are going to integrate first and third-party authentication, we first need to hash out some of the inconsistencies in our design. If you recall in the previous video, the third-party login on Azure AD only requires email, but in our first project, the login requires the username instead of the email, plus the password. We did this in the first project without real reason, mostly because the example Giraffe project we were using as a reference was done that way, but obviously we should just get rid of the username. Imagine we were working on a real project rather than a demo. In that case, we could just let the user set his username in a later stage after the authentication is done. This change will simplify our code a fair amount as well. Next. With our current level of understanding, making the right authentication challenge requests will not be hard. If the user selects Azure AD, we redirect him there. If he registers Onsite by putting in his email and password, then we'll use the cookie authentication scheme instead. But now that we have 2 different authentication schemes, how will we know which one to use in order to verify the token? Remember, the server is stateless, and the cookies are encrypted. So perhaps we'll have to try each schema in turn, to see if one passes. But even though we haven't covered it, the logout also requires an authorization schema to be passed into it. Do we want to iterate that as well? Or maybe passing in anything will work? We doubt it. Answering these questions is the purpose of today's video. In doing so, we'll deepen our familiarity with ASP.NET even further. Anyway, while I was talking, the project was being set up in the background, as you can see. We found that in general, when the projects are small, it is better to duplicate them and then modify that. What we will do next is streamline the pages themselves. We'll merge the login and registration into one, and add a link to login or register using Azure AD. We are done setting up part 3. As you saw, we merged the two login pages into one by merging and then factoring out their common functionality. What we'll do next is add a link for the Azure AD login. We'll have to do that in the login page, but not in the register page. The reason why we don't want it in the register page is that even after the Azure AD login is successful, it would redirect it back there. So in review, we were probably too aggressive in our factoring. Let's specialize the template. Done with that. We'll try running it just to check to see if the link is there. Right now, if we try clicking on it, we should get an exception because we haven't set up the middleware. We'll work on that next. If we try running the server after putting in the configuration options from the previous project, we get an interesting error. As you can see here, it says that the schema is already present. The reason for that is because we have two different services with the same name. As it turns out, if we hover over the Add Microsoft Identity web app, we'll see there are two optional arguments for cookie and schema name. One is for OpenID Connect, and the other is for cookies. From this, we can guess that after the service gets the OpenID token from Azure AD, it converts it into a cookie which then gets used in the process of regular authentication. What we'll do is simple then. We'll put in the names for the two schemas. Since cookies should only be created after a successful login, and given that the Azure cookie is present, we think we've logged into Azure AD successfully, but we have a problem as the Authenticate Async is checking for just the Onsite one. What we have to do instead is try to authenticate using each of the cookie schemas in turn. If one of them is successful, then that will be good enough to serve as login. We'll do that, but we need to highlight how the recent exception squishing caused cracks in our overall design. In the previous videos, we mentioned that common functionality should be factored, and passing in raw strings like we've been doing in multiple places is poor form. Let's start by factoring that out. We'll also name the Onsite cookie schema explicitly. Now that we have that authentication all function, it will check all the schemas in turn. Let us try running it to see if we got it right. We should have. And in fact, we did. Unfortunately, the only problem is that it is not showing the email correctly. We'll open it in the debugger to see what is going on. Before that, we'll also put a divider on the Azure AD link so it isn't on the same line as the button. Looking at the values in the debugger, we see that instead of email, we have the preferred username key instead. We'll have to use that to get the email then. We'll also use that as the claim name in the regular login. We actually have both of the logins complete now. Congratulations are in order. But we can go a bit further. We've been delaying this forever, but now that we've come this far, how about we finally do the logout? At the start of the video we were wondering how that could possibly work since we will have two different schemas, but now that we know we have different cookies for each, it is easy to infer that all we have to do is log out each in turn. This will be easy to implement. After logging out, we can either do the redirect ourselves or we can put the logout path into the configuration. Let's do the latter for demonstration purposes. So far, trying to make use of the logout paths is more annoying than we thought it would be. The redirection isn't working at all as expected, and the sign-out callback, much like the sign-in, is intercepting the requests sent to that path. We also made another mistake. Let us show what it is in the debugger. If you look carefully, you'll see that is authenticated says false. If you think about what happens when the user clicks on logout, it makes sense. When the client sends a new request, the server doesn't have any memory of it. Since the request hasn't been authenticated, of course it would say that. So if we wanted to log out, maybe it would be better to try authenticating the user first and then getting the authentication schema from the claims principal. Let us give it a try. We've coded it up really quickly, and if we look at the fields in the debugger, we see that the authentication type is something completely different from the schema name. The experiment is a bust. We could also test whether the logout redirect works for the Onsite cookie, but since the Azure one doesn't, even if the Onsite did, we can't use it. We don't want the redirection behavior to be different for different logout types. So since we can't control logout redirection and can't get the schema, we'd be best just logging out all of the possible cookies and redirecting manually. Let us implement that now. We'll leave the mystery of the sign-out paths for a different video. That clears part 3. If you found this video useful or interesting, click those like and subscribe buttons. Thank you. If you want our advice, just get rid of the on-site logins. Let your favorite megacorporation take care of user security instead. We didn't care too much about encrypting the passwords we are storing in the database, since it is just an in-memory one, but if we were working on a real site, it would be a security risk to store them unencrypted like we are doing here. But if you still wanted to keep track of the user passwords in your own database, a way to do it safely is to use the ASP.NET Core Identity Library, as it makes it easy to store the passwords in an encrypted form. The library also offers an easy way to do password verification. We'll cover that briefly in the next part of the mini-series. After that, what we want to cover are logins for single-page applications. We think after we've covered that, we'll have everything we need to deal with most of the authentication scenarios in the wild. The road to that Twitter clone that we mentioned is a long one. By now we've already decided that we'll skip and instead do the projects we wanted in the first place. We'll talk about that in the future videos. I'm your host and AI assistant, Vilo. Stay tuned for more programming videos on Ghostlike's channel. We'll be back after the break.